5, 4, 3, 2, 1. Hello.
Hi.
I'm Erik Meijer. We have you again on Channel 9. This
Yes.
time it's just you.
Yes.
Last time you've been with a couple of people,
Yeah,
right?
that's right. That was with Brian and with Amanda and with Paul Vick. So yes.
Cool. So what are you working on these days?
Yeah, so I'm still working with the C# team and the VB team on Link. So
Okay.
we're trying to kind of get that shipped.
Cool.
So that will take a while. So that's in the end, it's always much more work than you think to kind of ship something. You know, it's like you think that everything is done, but once you really start working towards shipping, you know, there's always kind of a lot of loose ends to tie up.
Mm-hmm.
So we're working on that, and then I run a little what's called an incubation team called Tesla, where we're looking kind of more into the future. So we're looking ahead, you know, what's next.
Mm-hmm.
And our team there is what I call democratizing the cloud. So it's just like Visual Basic democratized programming Windows like many years ago.
Uh-huh.
Now we want to democratize programming distributed systems.
Interesting.
So
does that mean it'll be VB?
Yes, definitely. So yes, I think it's VB is kind of uniquely positioned, I think, to play that role.
Mm-hmm.
Not only because I think it has the target audience, kind of just the normal programmers, you know, like the blue collar programmer, as I call it, but also because technically it's, I think, superior to many of the other programming language that we know of. Mm-hmm. So I mean, I can explain that more if you want. Or
sure, absolutely. Let's dig into that a little bit.
Yep, okay.
Sure.
So, like, I don't know, these days there's a lot of hype about dynamic languages, right? Probably you heard about that, like things like Ruby and Python and so on.
Mm-hmm.
And then on the other hand, there's the kind of classic, you know, statically typed languages like C# and Java. So I think both of these camps are kind of too extreme. So the problem with dynamically typed languages is that, you know, it's like driving without seatbelts or having, you know, unprotected sex or whatever. It's it's like you're throwing away all safety nets, and there's no kind of feedback from the compiler. So the compiler doesn't help you. So all bugs and all errors are only detected at runtime.
Mm-hmm.
Then on the other hand, statically typed languages are kind of too strict. Is that they kind of require you to kind of, you know, that your program is kind of type safe and so on before you can actually run it.
Mm-hmm.
But usually you want to have something in the middle. So you want to have like static typing where possible so that the compiler can help you whenever it can. But sometimes you need some kind of dynamic typing when you need to have dynamic class loading or you don't know the type statically or so on. So you want to have the kind of golden middle.
Okay.
And it turns out that Visual Basic is kind of the only language that's kind of, you know, widespread that has those properties. So I think that's kind of, you know, a really unique position. So it strikes really the golden middle between the two kind of extremes.
So you're VB.net, you're saying?
VB.net,
well,
yes.
let's talk about that for a moment. I mean, how do you ensure type safety if you're not compiling, if it's not type safe? In other words, how is code verifiable if you don't compile it?
Okay, so now if you talk about verifiability in the CLR sense,
sure.
Yes. So well, if you're compiling to IL, then the bytecode verifier kind of, you know, checks your code. So, but still the CLR allows you to do kind of dynamic, a lot of dynamic things via reflection, for example.
Okay.
And that's kind of also shows why the kind of purely statically typed language are kind of bogus, because if you're using reflection, everything is statically typed, but you're still doing things kind of at runtime. And so there, you know, the fact that it's statically typed doesn't help you much, because, you know, it can still go wrong at runtime. But there's in Java and C#, there's a lot of syntactic overhead because you have to kind of manually do reflection. And in VB with late binding, that's all done for you by the compiler. So it's kind of still safe in the sense that, you know, you cannot accidentally use a pointer as an integer or an integer as a pointer. But you can do you can call methods on objects where you don't know statically that these objects support these methods.
Interesting.
and of course, you can do dynamic class loading and like reflection emit and all those things. So there's a lot of dynamism in the system that you can do, and VB gives you kind of a very nice way to do that.
Excellent, and that's today, right?
That's today.
V.NET 2005.
Yes.
You have that function, and you mentioned because of late binding.
Yes.
So you're saying you don't have late binding in C#?
No.
Okay.
So you have to kind of do it by hand.
Okay. Using reflection.
Using reflection, yes. But then on the other hand, now if you look at a language like Python or Ruby, there you don't have early binding, which means that you don't get IntelliSense, you don't get any compile time checking, or like if you add two integers, you don't know statically that they're integers, so you always have to do kind of expensive, boxing and doing the addition and unboxing and so on. So perf is really bad. Plus that you get less checking.
Sure.
So sometimes there's AMD now has this kind of campaign where they say how much energy you can save by using more power efficient servers. I think also if you use more kind of slightly more statically typed languages, we would save enormous amount of computer cycles. And
Sure.
so I think in fighting global warming, I think we should kind of abandon kind of purely dynamic languages. And then for our own kind of mental soundness, we should use more dynamically typed language. So in the end, you end up with VB. So
Sure. Now, remember that thing we used to have called JScript.net?
yes.
Whatever happened to that? I mean, that certainly fits into the category of what you're talking about, doesn't it, to some degree?
Yeah. So JScript.net was kind of interesting. It was an implementation of JavaScript that also supported some form of type inference and static typing. Actually, I'm not sure what happened to that. But what's definitely the case, if we're not talking about JScript.net, but about JavaScript in particular, that is, I think there's an enormous kind of, interest again in JavaScript.
Exactly.
In the sense, if you look at all this whole Ajax hype, and in some sense, the interesting thing is that JavaScript has become the kind of universal runtime in some sense. So it's kind of, we sometimes think, it's like the CLR is the universal runtime, or some other companies think that the JVM is the universal runtime. But I think in practice, it's JavaScript that's the universal runtime. And you see that there are a lot of languages that are actually targeting JavaScript. So they're compiling to JavaScript. So, for example, a good example is Google. They have a Google Web Toolkit where they compile Java to JavaScript so that you can run Java programs in any browser. But also academic languages like Scala or Lynx, which not to be confused with Link, they are also kind of using JavaScript as a target platform. And I think that's kind of an interesting opportunity, because I think JavaScript is kind of a weird language, to be honest, and I think a lot of programmers don't want to deal with all the complexity of JavaScript and dynamic HTML and CSS and so on. So by abstracting from that and just kind of looking at JavaScript as just another like x86 assembler or IL, I think that opens a lot of interesting opportunities.
Absolutely. Of course, the question would be if you're doing this from, if they're doing it from Java, which is a typed language, into a language that's completely untyped, right? There's no, object. You can make objects in JavaScript manually, right? Using the new function thing. It's a very strange syntactic way of doing it. So conceivably, then, what you're saying is I could write a program in C# and have it compile to JavaScript if I wanted to do the work of writing, the front end.
Yes, yes. So, but what I would rather see is to compile not C#, but compile IL to JavaScript, because then you can take VB or Eiffel or C# or any language that compiles to IL, and then compile that to JavaScript. So I think that kind of leverages the kind of the universal kind of idea of the CLR, and then you can kind of run that everywhere. And then the nice thing is that if your browser does have a CLR, then you can kind of fall back to a more kind of efficient implementation. But it gives you kind of a very broad reach, if you compile IL to JavaScript.
Sure.
And so we are I'm looking into that. That's kind of one of my little side projects in this incubation team.
Uh-huh.
So there is
very interesting.
a somebody called Audrey Tang. She is from Taiwan. She is an extremely talented person, and she has been working on the Perl 6 implementation. And she visited Microsoft a couple of weeks ago. So we are kind of looking with her to compile IL to Perl. And then they have an implementation from Perl to JavaScript.
Nice.
And then what they also want is to go from Perl to IL. So you kind of go both ways. So you can then run Perl 6 on the CLR.
Nice.
So I think it's kind of nice that there's this whole new kind of groundswell of interest in programming languages, and it doesn't matter where you start. You can kind of all compile them into each other. I think that's an interesting thing. So who would ever imagine that you would compile IL to Perl?
That's really cool.
Yep.
But because then you get the benefit of the CLR and managed memory and all that good stuff.
Yep.
Excellent. So you've done work in VB.net. We've done a lot of coverage so far in Channel 9 with Link, and some of the interesting work that's going on around in this area. We're in data world, pretty much, the idea.net team. And so you can write Link in VB.
Yes.
Right, and this can be done in a late bound way.
Yes.
Okay, which is not the case for C#.
That's true.
Okay, but you want it to be early binding so you can have the benefit of
IntelliSense, for example. Yes.
Okay.
So again, I think the fact whether something is late bound or early bound is something that how should I say? In the beginning, when you start programming, often you want to be very flexible because you don't, I don't believe in upfront design. So when you start to program, you have no real crystal clear idea of what you want to do. So you want to kind of have a more exploratory way to do things, and that's where kind of this late binding and dynamic typing helps, because you're not pinned down yet to a particular type. And then over time, when your application gets clear, the structure and the architecture gets clear, then you can start to add static types to make it more performant, to make it more robust.
Okay.
So it kind of really fits in the whole agile movement. So in some sense, I think if you look at the agile development, where people are always willing to kind of refactor their code and start with the most simple solution, I think this fits in really well with this idea of dynamic typing to start off with, because there you do the minimal thing to get your program working, which means you don't really think about types, and then kind of gradually you add more and more kind of static typing.
But now we should talk about how this really looks under the covers. I mean, what's going on with dynamic typing? Because in some sense, you have to know, you have to be verified, you have to be type safe if you're running on the CLR, right?
Yep.
So what I'm assuming is happening, and I'm probably wrong, is that you're doing the reflection for me.
Yes.
Okay.
Yes. No, that's exactly what we're doing. So as I said, when you're doing late binding, you're kind of at runtime inspecting objects and say, do you have this method called foo or something?
Sure.
And can you call it? So you're not kind of trying to take an arbitrary, pointer and kind of interpret that as an object. So,
sure.
And this is because in the CLR, all objects carry around with them their runtime types. So that's where you can, but you will never kind of add an integer to, a button. That cannot happen. So it's not untyped. So you have to be kind of careful to make a distinction between, static typing, where all the type checking is done at compile time, and then dynamic typing, where some of the type checking is done at runtime, and kind of untyped languages where there are no types, there are also no runtime types. And then, that's where you get kind of the traditional thing where people talk about unsafety, or where you can exploit buffer overruns or something, because you can take, an arbitrary pointer and then, call that as if it was a function or something. Mm-hmm. But that cannot happen. So in the CLR, if you run verifiable code, you're kind of in the sandbox. Mm-hmm. So that cannot happen. So it's really dynamically typed, but not untyped.
Understood. And it just like VB does classically, it abstracts
yes.
a level of complexity away from somebody, say, using C#.
Yes,
that actually
correct.
has to use reflection.
Yes,
okay.
and it's actually quite difficult to do this by hand, because if you have ever programmed in C# or VB, there's this notion of static kind of type-based overloading. So you can have, let's say, a constructor that takes an integer, and another constructor that takes a string, and another one that takes a boolean and an array of characters or something like that. And so the compiler, when you call the constructor, will find kind of the best match given the arguments that you pass. But now you have to do that. If you're doing late binding, you have to do this overload resolution at runtime. And reflection has all kind of hooks where you can give it resolvers. Mm-hmm. But to get the kind of right behavior that corresponds with the kind of compile time overload resolution is pretty hard.
Yes.
And the VB runtime kind of has, in some sense, a copy of the logic that the compiler uses at compile time to do overload resolution. So
understood.
I think the value that you get from late binding in the VB is pretty high. So it's not just a kind of a thin wrapper over reflection. It's a pretty juicy
language
layer.
feature.
Yes.
Because I know VB used to be able to not having to type.
Yep.
It can just be, it's going to be something.
Yep.
Here's my constructor. It's going to take something.
Okay. Yes. Yes. But
Which
then,
is interesting.
Yeah. But now at runtime,
yeah.
the kind of whole late binder has now to look at this argument and say, oh, it's a string, so now which overload do I pick? Which constructor do I actually call?
Cool, and that really does help, productivity and the agility thing you're talking about for the developer that is for the VB developer.
Yeah, but I would even say, even for the kind of, for every developer. Mm-hmm. So I, as I said earlier, I really don't believe in the kind of hardcore waterfall model where you start with your upfront design and you write down all your types and classes and your UML diagrams, and then before you even write a line of code. I think your IDE and your programming language, that's kind of some form of intelligent paper, and while you're kind of developing, you're learning more, and then you want to kind of refactor. So I really think that there the late binding really shines. And then of course there are also situations where you cannot get around late binding. So and this is especially like when we're talking about the cloud and distributed systems. Because so assume that I want to kind of aggregate certain web services, say one defined by you and one defined by my neighbor here. And now I want to kind of call methods or find properties on these objects that are returned by these services.
Sure.
But since these types are not under my control, I cannot define a common interface. So for example, both have a customer object, but I cannot define, say, I define an interface iCustomer and then tell you to implement it and tell somebody else to implement, because it's not under my control. I just kind of am a consumer of these things. But I do know that the objects that I get from you have all the properties of a customer. Say they have a name and an age and so on. So currently you're stuck with static typing because there's no type that I can impose after the fact on these two types that says that it's a customer. I cannot implement an interface on your type because it's not my type.
Got it.
So, and this is what the dynamic language guys call duck typing, because they say, well, if you give me an object that has a name and an age and so on that looks like a customer, it is a customer. So, and it's like if it talks like a duck and walks like a duck and quacks like a duck, it's a duck.
Yeah.
And this is where you need dynamic typing, because there's no way I can even statically type this.
So let me ask this then. It begs the question. There's really nothing stopping me as C# developer from writing a constructor that takes object, and then inside of the constructor tests to see if O is string, if O is integer. I mean, could do silly things like that.
Yes.
But that would compile.
Sure.
And that certainly would be runtime type checking.
Yes.
Right?
Yes. So first of all, if you want to make things statically typed, you would have to do you find a constructor that takes objects and then constructs one of your strongly typed objects. But of course, in there you will have to do dynamic typing. You will have to do kind of a dynamic type test. So
sure.
the other thing is that, of course, that's kind of less efficient because you're creating new objects. But the main problem is that you also lose the object identity if you're not careful. Because you shouldn't make a copy. So now you have to make kind of wrappers and so on. But again, now what you're doing is this is what I call retarded innovation. So now you're pushing the burden on the programmer, right? Because the programmer has now to do all the work, where I think the compiler writer has to do the work.
Sure.
So it's like, that's the whole goal of why do you have a programming language? Well, that the programmer has to write less. And yes, of course, you can do it by hand, but that's kind of the wrong way around.
Sure, especially in this age of immense abstraction, and it's getting even further that way.
Yep.
So, yeah, I mean, I agree with you. Focus on your algorithm and less on how to get it done, right?
Yep.
But at some point, do you foresee a language coming up that's completely where you don't really have to think about what's going on underneath at all? Like, I mean, you can still write code on the CLR that eats up all the memory on your machine, and nothing will run anymore. So you still need to be an engineer and kind of know what you're doing. So let's talk about that. But it's an interesting situation, especially as you start talking about these distributed systems, because tracking down bugs in distributed systems is very complicated.
Yep.
And so you want the code to be written by people who's kind of, you can be dependent on their objects, whatever they tend to be at runtime. So can we talk about that for a little while?
Yeah. So yes. So first of all, let me say that I don't believe that whatever you do, that programming will ever become easy. So you can make it easier by kind of removing the noise, but essentially, programming is kind of hard because you're trying to in one way or another instruct a machine to kind of achieve something, and you can make the abstraction level higher and higher, which is what I mean by removing irrelevant details, by removing noise.
Okay.
But in the end, you still have to be able to kind of crisply explain what you want to do, and maybe you don't have to say how, but you have to be precise what you want to do. And like, if we can go on a kind of slight detour there, I think one of the things that if you look at humans, the way we kind of get clarity is via dialogue. And currently programs or programming environments are very one way. So you type in your program and then you get an error message or something, or you get you run your program and you get an exception. But there's no dialogue, whereas in kind of when you look at human communication, there's often dialogue. So you ask me, oh, that's not clear, then I can try to explain. So I do believe that if we want to make progress and kind of make programming easier, that we have to have more kind of interactivity, because that in that sense the kind of compiler can ask me questions. So what do you really mean? So I really, and there's kind of people like, for example, at MIT that are looking at that kind of dialogue. So that's a very interesting thing. But that's kind of much more, I think, science fiction, and not really science fiction.
Intelligent compilers.
Yes. Then when you talk about distributed systems, like programming the cloud, yes, that's kind of intrinsically hard. So how do we make that easy? So I believe that there's a couple of things that we can use to make that easier. And one of them is, again, this kind of agile development. So in my ideal, you don't start off with writing your program in a distributed way. But again, because in the beginning you don't know. So you start off writing your application as if it was just a single tier client-side application. And then via refactorings, you kind of say, okay, now can I take this piece of my code and put that somewhere else? Or I have this API here, can I access that as a service? And then, you might want to turn some synchronous calls into asynchronous calls, which is like an important thing for a distributed program, right? You don't want some programs, if the network goes down, that it kind of completely locks.
Yes, agreed.
But again, I think that's you start off with by writing it just as a synchronous method call, and then you say now you tell the IDE and you say I want to change these and these into asynchronous calls, and then it will do the refactoring for you.
Excellent.
And then you can test this program while it's still on a single machine, because now you can have test tools that do fault injection or simulation, or kind of they simulate kind of communication delays and so on. So you can kind of learn about your code without having to really deploy it kind of in this kind of distributed sense.
Mm-hmm.
And then once that works, then you say, okay, now let me kind of do the distribution. So again, it's this agile style where you start with a very loose, no assumptions, and then over time by kind of refactorings and kind of manipulating with small steps your program, you make it into this kind of bigger distributed program where you have all the difficult problems.
Okay.
So that's kind of the programming methodology style.
Mm-hmm.
And then there's also kind of programming paradigms that you can use to make reasoning about kind of concurrent and distributed programs easier. And there's kind of several layers there. So one thing I think at the lowest level, currently we are using logs and monitors and whatever, compare and swap exchange, things like that, which are really low level and that nobody can understand. You cannot reason about your programs at that low level of abstraction.
Mm-hmm.
Now the database guys have used transactions for decennia,
Totally.
right?
Yes.
And there's now a surge of interest in having transactional memory as well. And I really believe that's the only way normal people can understand kind of shared memory concurrency. I mean, you can explain to everybody, right? I want to buy chocolates and flowers, but I only want to pay if I can get both. And if I cannot get both, then I don't want to do anything. Mm-hmm. So this idea of an atomic transaction that either succeeds or fails as a whole, and when it fails, nothing has happened. I think that's very, very simple to explain.
Okay.
And also when you're thinking about kind of distributed systems, right? You want to have this notion of transactions because you're doing kind of things across the network, and again you want that either to succeed as a single atomic action or fail, all fail together.
Excellent.
So transactions I think are very, very important, and it's good to see that people are looking at that. For example, in Microsoft Research Cambridge, they're doing really nice work on software transactional memory.
Tim Harris and company.
Tim Harris,
Yeah.
Simon Peyton-Jones. So you probably talked to them.
We will, and
already.
I think I might actually talk to them in Cambridge in sometime in August, because I'm going to be traveling to India for some Channel 9 work via London.
Okay, you definitely should do it.
Yeah, because I just talked to Jim Laris and company yesterday for Singularity, and of course they're playing around with transactional memory in their system because you can just plug it in and see how it works. But anyway, sorry to interrupt, but that's
Yeah. So no,
exciting
that's
stuff.
yes. And then of course there's So that's kind of really, really cool stuff.
Mm-hmm.
And then the other thing I think is if you're thinking about like things for the other thing is that concurrency is getting more and more important even on your single machine, like with many core and things like that, and GPUs. And there are interesting developments like Accelerator and things where you want to do data parallel programming.
Mm-hmm.
So in many cases you can express your computation in a very natural way to do this data parallel programming.
Okay.
And one of the things there, I think there's a big opportunity for LINQ, because if you look at a LINQ query, where you're kind of doing, you're grabbing data from different sources, you're kind of doing some operation on that, you're filtering some of that, and then you're grouping it and aggregating it. So these are things that are very naturally parallelizable. like things like once I group, and then when I aggregate over each group, well, there you don't even have to think about that. That you can do that in parallel.
Interesting.
So we're, especially for in Visual Basic, we're working on making sure that the link query comprehensions have this capability to do this aggregation with this idea in mind that we need that to do this kind of data parallel programming, and that you can map these comprehensions then onto a parallel machine, a data parallel machine. So the user kind of just writes kind of a SQL query, select all the customers, group them by state, and then take the average salary and the kind of maximum age, right? And now you write just that query, and now the compiler can take that and run that in parallel.
Nice.
So again, you're abstracting from all these details by giving a very high level specification.
Awesome, and I mean that's unbelievably important when it comes to parallel systems.
Yes, exactly.
And some fantastic work that's being done, and you clearly know about this, the coordination concurrency runtime. And we've had that on Channel 9 for a few times, and in fact, somebody, one of the robotics developers, had written a build system using the CCR, where they actually took advantage of the 4 cores, right? And so maxed out all 4 cores doing parallel operations using a relatively, a very approachable, understandable syntax, and increased the speed of the build by 4 times, right? I mean, it was really impressive to watch that. That's cool stuff as well.
Yes. So that's actually my kind of third layer of concurrency. So I kind of this is like David Callahan describes this as the concurrency elephant. So it's like where you try to you touch this thing, but you don't know that it's an elephant. With concurrency, it's the same. There are many facets of concurrency. So like the first one was this kind of shared memory concurrency, data parallelism. The third one, where the concurrency runtime comes in, is when you want to do high-level synchronization. So for example, you have different web services that you call, and now you want to synchronize over them. So you want to say, well, if this one comes back but not that one, or 2 out of 3, so where you want to have kind of high-level synchronization patterns, or sometimes they call that join patterns.
Certainly.
So and that's, I think, the kind of third level. And then there's several approaches. There's the CCR, but there's also a library from MSR Cambridge, the kind of join library. Claudio Russo worked on that, Nick Benton, Luca Cardelli, Cédric Frounet. So if you go to Cambridge, definitely talk to them.
Is that where you came from? I mean, you seem to know a lot of people there. I mean,
no,
are you from research or?
No, I used to be a professor in a university.
Excellent.
But then I felt like I was a vegetarian butcher. So I was teaching software engineering and so on, but I had no clue what I was talking about. I never written more than toy programs. So that's why I decided to kind of join industry.
Excellent.
But a lot of people think that I'm in research. So if I would get $1 for every person that thinks that I'm in research, I could retire.
Well, I mean, look at all that. You have quite a few patent cubes going on, and you kind of look like a researcher.
Oh,
that's
okay.
a compliment. I mean, but and the things that you think about are not necessarily the what are we going to deliver in 2 years. You're thinking about the 3 to 5 to 10 year plan about. For example, where's VB going? We're at this snapshot, but here's where it should be 3 snapshots down.
Yes.
So that's more of a researchy kind of thing.
Yeah, so I think that's why I think, I run this incubation team, and it's called Tesla. And I don't know if you know Nikolai Tesla. He's kind of, was a great inventor, early last century. A lot of the wireless stuff that we're using was invented by him.
Wow.
But one of the things that we see ourselves is like a transformer. So we transform research ideas into product ideas. And there's kind of a big kind of impedance mismatch between research and production. And we're kind of, at this boundary where we, since, we know both the kind of research, we can understand papers with Greek letters and horizontal lines in theory, but, also since we know work with the actual product teams, we know how to ship stuff. So
certainly.
So that's kind of where this, I think, the incubation kind of really works well to bridge this gap between research and product teams.
Well, that brings up a actually rather interesting point in terms of when you talk about agility, you're really talking about a product team in the sense that we're going to, like, for example, the classic case is we're going to release, little features on top of our platform every, 3 to 6 weeks. And we're going to have these rushes, and we're going to have developers, and everyone's going to be working together. It's going to be great, and everyone's going to be happy. But when you're dealing with research, it can't be like that, because with a research problem, it's hard to be agile with a problem like, can we write, like the singularity problem, right? Can we write software that's, an operating system that you can completely verify, you can trust, right? And can you ensure that a process can never affect the memory of another process? Those are much larger problems, but what I would be interested in knowing is how can you be more agile with research? How can you take some of the things that they've figured out that are pretty solid, not fully solid, just start trying to use them? Can that happen, or is that impractical?
Well, so I think that's kind of a real challenge, and I think this is what our team is experimenting with, because I do believe that there is this transformation going on. So there's a transformer which kind of heats up, and it's a big difference.
Mm-hmm.
Because one of the problems with research, or one of the problems, that's not the right word, but in research, the kind of, you get judged on different things.
Mm-hmm.
And as a result, you often abstract from details that are kind of relevant in practice, because you're trying to simplify the problem to kind of go to the core, so that you can understand the kind of main problems.
Mm-hmm.
But then when you take that into production, you often have to, the biggest problem is not solving this kind of deep problems, but how does it fit with legacy, and how does it, like for example, when you're designing a language, how does it fit in Visual Studio, how do you do syntax highlighting, so on. So there are kind of completely different constraints, and so there's this gap. And I think personally that Microsoft is very bad at this. Because what you need to do is you have to have a constant pipeline of innovation between research and product, such that like you take an idea from research, then you put it in this middle phase, this transformation phase, this incubation phase, where you kind of look at all these other additional problems, and then you can put it in production. So what I'm looking for is to have this kind of continuous kind of pipeline, where you have a continuous stream from research to product. And what happens now often is that once we've shipped our products, then we scratch our heads, oh gee, what are we going to do? But we don't realize that it takes many years to take this idea from research and kind of bake it enough to put it in production.
Sure. And that goes back to the original question is, does it have to be that way?
Well,
that does impede innovation on the product side. You can have incredible innovation in research, but like you said, they're in a different domain.
Yes, but the thing is, the way to speed that up, I think, is to have to realize that you need this kind of third thing in the middle. You cannot take something from research into product. You have to have this buffer, and in that way, things will automatically kind of become smoother, but also you can take, if there's one idea that kind of can be sped up, you can kind of push that through the pipeline faster.
Excellent.
But I think this is something where Microsoft could improve, is to really kind of invest in this incubation in the middle, where you take ideas from research and you make them ready for practice.
Excellent.
And researchers also, to be honest, I think should have the freedom to really solve weird problems. So I think you see that in universities, and you see that in industrial research labs, is that there's a lot of pressure for them to be relevant for products. But I think that's kind of the wrong approach, because now you're kind of compromising the kind of what you're saying, the real hard research problems. So that burden should be on this middle group in this incubation. That should say, okay, now we understand research, we understand product, now let's kind of combine the two.
That's fantastic, and I would just interject, because right on today I just released an interview with Craig Mundy, who, as you know, is now the Chief Strategy and Research Officer for Microsoft. And the conversation, we actually get into things like this, and so I think that we may be heading in that direction. I can't speak for sure, but, hopefully he'll watch this video and you guys will communicate somehow, through a proxy such as Channel 9. But the point is, that type of thinking is, we do have that at the top now.
Okay, that's
not that we didn't with Bill. I don't know exactly, but the point is we do have that in the top now with Craig, because he is overseeing all of research and at the same time strategy. And he came to Microsoft to be sort of a startup kind of guy, and was on the Big Top project and the CCR and all that stuff. So this is goodness. I'm glad to hear that. So maybe that is the way we're moving.
Yeah.
And we need people like you, right? You have to have the middle tier.
Yes.
You have to have the incubation people who are going to have to be engineers and architects that actually can interact successfully with the research and understand and be able to figure out what do we pull in and how do we use it. So maybe that's a new class of architect or engineer at Microsoft. I don't know.
Yeah. No. I really find that it's always the edge, the bleeding edge between kind of theory and practice. That I think is for me interesting personally, but also I do believe. I agree. If it's good to hear that that high up they're thinking in the same way, because I think if you're talking about what kind of keeps us from growing, I think it's that.
Absolutely.
And you cannot expect, and you should not expect that from researchers, and also you shouldn't expect that from production people. That you cannot tell them to say, now go and read this paper in the Popple proceedings, because it's probably it's easier for them to reinvent that than to kind of really understand all the lingo and the notation and so on.
Absolutely. So what are you most excited about with VB in this release and what you're working on? Since this is what your brain is on right now.
Yeah. So for VB, I'm kind of most excited about the XML support. This is something that we kind of added, which is very different in VB than in C#. So one of the things that we did in the general link context is that we had to create a new XML API. The current XML API shows its age in some sense. It's very imperative, so it's all very statement oriented. So the way you create an XML document is you create an empty document and then you kind of imperatively add new children to that. So you create a new node and then you add that. So it's a very kind of bottom-up imperative way to create documents. But if you're now doing queries, like in Link, you have to have an expression-oriented way to do queries, because you're saying, you're pulling stuff from different sources, and then in the end you want to say, now return this as an XML document. So you have to be in an expression context. So what we did is we designed this thing called Xlink, or as it's now called, Link to SQL. I think that's the new marketing term, which is like an expression-oriented API for XML. Now what we did in VB is we took some of the old work that I've been doing on X# or C Omega, as it's known, where we had kind of XML deeply integrated into the programming language as a first-class type, just like strings and integers. And we have added that to VB on top of this new Xlink API. So now in Visual Basic, XML is just a first-class citizen, just like strings and integers. So you can take an XML document and you can cut and paste that into your VB program. And for example, if you want to kind of create a web service in VB, well, you can just write the XML as it is without having to kind of construct that. Again, you're removing this kind of extra barrier by raising the abstraction level, because if I'm dealing with XML, I want it to look like XML.
Absolutely.
And so that I think is really, really nice. And again, that took a long time, because I started Wolfram Schulte and I wrote a paper in 2001, a Bill G paper on XML integration in C# by that time. So it took 6 years to go from that idea, a research idea, to the actual product that will now ship. And you see, and we went to kind of several iterations where we went way too complicated, where we were still way too researchy, where we were incorporating XSD types and doing really complicated stuff. And then we kind of had to simplify it down to what it's now.
Excellent.
So, and this is like another example, right, where you take this research idea, simple idea, and it takes 6-7 years to move it. And I don't see how to speed that up except by having this kind of pipeline going on.
Sure. Or something could be like sort of a research.microsoft.com, but not the website, but sort of the concept where you have these things just coming out, and then play with it, figure something interesting out, or maybe it'd be an internal thing like, check this out, like here's the SIP idea.
Yes,
do something with it.
But the problem with that, right, is if you get all these things kind of thrown at you, how do you
ship a product? That's what I'm saying. But it could be that you have you mentioned this new tier. It could be this new line of product engineer and architects and division in all these product groups. Or what they do is, like you're saying, they're the incubators, and they are able to help us, as you say, transform the research into the lot. So we help developers out on the outside and customers, etc.
Yeah, and also I think there's logically there's also a flow the other direction, right?
Sure.
Where you're kind of there might be problems that the developers have, and you want to now say to the researchers, now here's something that we don't know how to solve. Please, help us.
Absolutely.
And I think that's something I think that's working relatively well. So, for example, again, if you look, if you're going to Cambridge, like Simon Peyton-Jones and Simon is working with the kind of Excel team, for example, on how to improve Excel, and so there are a lot of interesting things where the people from the product team say, we have problems here and questions, so can the researchers
help us
solve
out.
that?
Well, that's a great use of the resource.
Yes, and for example, I've been working also with Gavin Bierman from Cambridge on formalizing the whole link stuff. Because there, we are doing a lot of the work there, but now how can we now take the work that we've done and put it into a form that the researchers understand, or that the researchers want. The researchers don't want to rewrite our language specs in English. Researchers want Greek symbols and mathematical formulas. So there, it's kind of funny that we're going kind of the other way around.
Sure. Interesting.
Yes, and I was, last week I was at a workshop in Boston, and it's actually here, so I worked with Phil Watler here. So here you can see, let me show you the Greek symbols and horizontal lines. So this is
generalized comprehension. Let me get
so I don't know if you can see this.
Yes, now we can. Generalized comprehension.
Yes, so you see this is kind of full of Greek symbols and kind of strange squiggles.
Yes.
So what we're doing here is that if you look at LINQ, the idea of LINQ queries were inspired by monad and monad comprehensions in Haskell. And now what happened is that, we are kind of inspiring them again, because now they're talking about generalized comprehension. So it's kind of really the nice circle where this idea LINQ that came from the research community is put into the product development. And then we did some generalizations, and then I'm taking them back to them and saying, look, this is what we learned. And now I'm working with them to kind of, also translate this again in what but no developer would understand this here, but this is what they want. So that's kind of, that's the nice, interesting kind of,
that's fantastic.
Bi-directional communication between the product and then the research world.
Fantastic. Well, this has been awesome, and I appreciate your time.
Thank you very much.
You're very busy. And would love to come and talk to you again, see what's going on.
Okay.
And thank you.
Okay, good.
Take care.
Okay.
Nice to meet you.
Bye bye.